Hey guys, I hope that I'm live right now. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please do let me know, guys. Good evening, everyone. Good evening. How are you guys? I hope that I'm live right now. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please do let me know, guys. Hello, everyone. Okay, great. So, no issues with the audio or the video. Everything is working fine. Good evening, everyone. Good evening. Good evening. Good evening. Okay, so how was your day, guys? Please do let me know. How was your day, guys? Please do let me know. Okay, it was good. Okay, that's great. Great. Amazing, guys. Amazing. Good evening, guys. Good evening. So today we are going to continue with our boot camp and we'll start learning NumPy. So that is our aim for today. Okay, so let me just open up the notebook for NumPy and share it with you guys as well. So yes, think so. NumPy is this one. Let me just check. This is the NumPy notebook. Let me just share it with you guys in the live chat. We'll be using this particular notebook today, guys. Okay. I've pinned today's notebook in the live chat as well. You will be able to access it from right over there. Okay. Okay, great. So yeah, so once we have completed with all the things that are necessary for us to start learning NumPy as of this particular point of time in Python. So we'll continue from right over there. We'll try our best so that we are able to learn as much as possible. Okay. Yeah, there's a little bit stream delay today because I started the stream immediately. I didn't saw that the default option for the stream has been set to normal. Usually I take it up to the like most advanced one, but no issues in that. Okay. When is backend bootcamp? I've registered it for 7th July. Vibe with Sudip. We just had our very first class from 6 o'clock. So I just completed that bootcamp at 7:45, and then I started with this particular bootcamp. Why with Sudeep? We have already started with the bootcamp. It is from 6 o'clock. Today was the bootcamp itself. So that is for Vibe with Sudeep right over there. Okay. Okay. So today our main goal is to start off with NumPy. Okay, we have completed everything that we need to know about Python. So we'll be continuing from right over there, guys. I hope that you guys are ready to start learning the new topics as well. That would be our aim. Okay. Okay, that's great. So somebody is trying to like the video itself. Okay, that's amazing. Okay, so should we start off with our today's class, guys? Please do let me know. Should we start off with our today's class, guys? Please do let me know. Good evening, everyone. Good evening. Yeah, personally, I a lot many number of people have followed me right over here, as well as on DevTown's channel. Okay, so you guys as well, please go ahead and follow us on our DevTown channel. It would be great to be able to connect with you guys as well. We are hoping that in this bootcamp we are able to cross at least 20,000 followers on the main channel of DevTown, and it would be great to connect with you on a personal level. So if you are want to connect with me directly on Instagram, you can go ahead and do that as well. Okay. Okay, so should we start off with our today's class? Please let me know. Okay, great. So let me just go ahead and turn it to only subscribers. Save. So let's start off with our today's class, guys. Numpy. So Numpy is one of the most important libraries or packages, you can call it as anything, that is currently there in Python. It has a lot of different applications, but of course, it's the full form of Numpy is numerical Python. So you're easily able to understand that this package or this library is basically used for scientific computation in Python. Now, what do you mean by a package, or what do you mean by a library? So when you think about a library, what comes into your mind? A library full of books, full of knowledge that you're able to go, and somebody from across the world has written all his knowledge, everything that he or she knows into a particular book, and that book you are able to access from a library and learn from it and use that concepts as well. The same goes on with libraries or packages in Python. So somebody from across the globe has created this entire code base for you. Okay, has created an entire code that basically helps you do the scientific computations easily. And instead of writing all that code from scratch, you are able to just use this particular library to be able to do that. For example, if you wanted to calculate the mean of a particular array, we have learned about lists right now. Okay, we have learned about lists. So if you wanted to calculate the mean of a particular list, what are the two different things that you will be using to be able to calculate the mean of a list? Using just normal Python. We have already learned about it. Okay, so what is the formula for mean? Can somebody let me know in the live chat, guys? I'm just opening up the live chat on my mobile phone. Up to that point of time, guys, can you let me know what is the like formula for calculating the mean, guys? Can somebody let me know that? Can somebody let me know what is the formula for calculating mean, guys? That I'm just opening up the live chat on my mobile phone so that I'm able to see the live chat as well. Yeah, sum of numbers divided by the total number of numbers. So for a list, how will you be able to do that? You will be using the sum and the length property. Okay, you will be using the sum and the length property right over there. Now you of course know, like for a list, to calculate the sum of a particular list, you will be using the sum function, and to calculate the length or number of elements in a particular list, you'll be using the len or the length function right over there. So now we need to understand, why do we require NumPy? So we know that we can directly calculate the sum or the length and like calculate the mean of a particular list using just normal Python. But why do we require NumPy for the same? So what we are going to do right now is so this particular line of code, you don't need to understand it. Okay, this entire line of code, again I'm saying, you don't need to understand it. What I'm doing right now is I'm just trying to make you guys understand why NumPy is important, why NumPy as a library is so essential for us. That is the only thing that we are going to do. So you don't need to understand this particular line of code, guys. You just need to look at the answers that we are getting. Okay, so let me run these particular lines of code for you guys. Okay, so it will just connect me again. Like I said, you don't need to understand the code. Okay, you don't need to understand the code, you don't need to look at the code as well. We are just going to look at the results. Okay, this is meant to be trying to understand why we need to use NumPy. Okay, so right over here we are running these particular lines of code. Okay, I think so. I just got this. The internet got there's a shortage of light. I know that you guys might not be able to see me right now, but don't worry. Okay, I think so the internet should be working absolutely fine so that you are able to at least hear me properly. Okay, so if there's any problem with the audio or the video, please do let me know. Okay. Okay, so let's continue with this right over here, guys. So I'm just like right over here, I'm using this particular line of code to create a 1 billion character long list. I'm using this line of code to create 1 billion number of elements are there in this particular list. Okay, 1 billion elements are there in this particular list. Okay, you don't need to understand this code. What I'm saying is this code is used to create a line. Okay, it's used to create a list of 1 billion elements. Again, you don't need to understand it, just listen to me properly. Okay, in this particular part of code, we are checking how much time does it take to calculate the average, the mean of this entire 1 billion element long list using just Python. Okay, so we are calculating the mean is equals to sum of all the elements in the list divided by the length of all the elements in this list. So if I'm running this little line of code, you will be able to see the exact time in seconds that it took to create this entire mean itself, to create the average. Okay, again, you don't need to understand this code, you just need to see. Okay, and you just need to see how much time it takes in just normal Python to calculate the mean of 1 billion element long list. As you're able to see, it is taking a lot of time for it to run. The notes are there in the live chat. I've pinned up the notes in the live chat, guys. Just look at the pinned message. I have provided the notes in the live chat, so please focus upon what I'm teaching and keep an open mind. Okay, so as you're able to see, it's still running. It's taking so much time to run this line of code. It's still running right over there. Okay, so just like take it a second or two to like complete it. Okay, Bhavin Dhobi, I have already provided the link to the notes, the collab notes, directly in the live chat, so you are able to access it from right over there. Okay, the notes are link is pinned in the live chat, guys. Yes, Bhavin Dhobi, it's a comment like it's of collab itself, and it contains all the notes. You'll be able to access it from right over there as well. Okay. Yes, the RAM is also filled up. Why is that the case, guys? Why has the RAM, we have almost used up from our 12 GBs of RAM that was provided to us, almost 8.3 GB of RAM has already been used by us, because our 1 billion element long list is getting saved inside our RAM itself. That is the reason why it is like it is using so much space. Okay, so right over here, as you're able to see, it took us 86 seconds, 86.76 seconds right over there to be able to calculate the mean of all the elements that is present in that particular list using normal Python. But when I'm doing the exact same thing using just NumPy, right over here, I'm using np.mean. I'm just using NumPy. I'm using the method mean of NumPy right over here. And if I'm calculating the mean of the list using just NumPy, it took me just 0.67 seconds. It is just taking me 0.67 seconds. Python took 86.76 seconds and NumPy took 0.67 seconds. So NumPy is very, very, very fast in doing scientific computations, and that is the reason why we use NumPy, and that is the reason why we use NumPy. Are you guys able to understand why we are using NumPy, guys? Can you guys let me know? Are you guys able to understand why we are using NumPy? It took us 86.76 seconds, or more than 1.5 minutes, to calculate the mean using normal Python, but it took us less than a second to calculate, almost half a second to calculate the mean using NumPy. And that is the reason why we prefer NumPy over normal Python, and that is why NumPy is so famous and used so much widely. Are you guys able to understand this? Please let me know, guys. Amazing. So let's try to understand how to import NumPy. Okay, the first thing that we need to know is how to use NumPy. To be able to use NumPy, you need to start off with import NumPy as np. Now, what is as np? So we have to import NumPy as a package. Okay, there's the package that exists in Python. So we need to tell Python that we need to utilize, we are going to use the NumPy package. So for doing that, you just write import NumPy right over here, and then again as NP. So instead of writing NumPy again and whenever we are using NumPy, you'll have to write NumPy again and again. You don't want to use it. So we are providing it a nickname. Okay, we'll be calling it as NP. So we are providing it a nickname right over there. Okay, we are providing it a nickname right over there. So we are calling it as NP. So anywhere we want to use NumPy, we'll be using it as NP, using the nickname. Now in NumPy, there's a concept called as Ndarrays. It looks very similar to your Python lists. Okay, it looks very similar to your Python list, but NumPy arrays are way faster and way more efficient than normal lists in Python. So these are called as ND arrays or n-dimensional arrays. It can be one-dimensional, two-dimensional, three-dimensional, and so on and so forth. For example, a one-dimensional ND array would look exactly like a list. A one-dimensional ND array would look exactly like a list. So this is an example of a one-dimensional ND array, guys. Okay. So this is how a one-dimensional ND array will look like. So this is a 1D array. Okay. The next is a two-dimensional ND array. Okay. This is a two-dimensional ND array right over here. Okay. So this is a two-dimensional ND array and this will be called as 2D array. Okay. Again, there is a three-dimensional ND array that will look like a cube, like a structure. Okay, so that will be called as a 3D array. Okay, so as you're able to see, you can have like 12 dimensions, 13 dimensions as well. But of course, that is not something that you need to understand as of this particular point of time. But in arrays, okay, in NumPy, arrays are basically way more efficient when compared to your normal Python lists. Okay. Okay, so to create an ND array, you convert a list. Okay, you convert a list to an ND array. That is how you are able to create a NumPy array. To be able to create a NumPy array, you basically use NP. That is the name that we have. You can use it as anything. You can name it as Shaurya as well. Okay, so it will be like Shaurya. Okay, it will be Shaurya.array right over here. You can name it as anything. That's just a nickname right over there. Okay, so now we are naming it as NP because that is the convention. Okay, that is the convention. Wherever you are using NumPy, you usually nickname it as NP itself. Okay, you usually nickname it as an NP array. Okay, so we are going to create an ND array, one-dimensional array using a normal Python list. Okay, so to be able to convert a normal Python list to an ND array, to be able to convert a normal Python list with into an ND array right over here, you're going to write np.array. Okay, np.array that will convert your list, and then the list that you want to convert into an ND array, that you want to convert into an ND array. So please reply, is time related to algorithms? We are not learning about algorithms. Please focus upon what we are learning right now. Yes, time is a very important attribute to algorithms as well. Okay, but again, we are not learning about it right now. Please focus upon what I'm teaching. Don't go off topic. There's a lot that we have to learn as of this particular point of time. We don't have enough time as well. Okay, so please focus upon this, guys. So np.array and the list that you want to convert into an ND array. So if you are running this line of code, we will first import NumPy. Nickname is at NP. Then we are using the np.array to basically convert the one-dimensional list. Okay, you are able to convert the list to a NP array or a NumPy array, and then you are able to see this is your NumPy array that you are able to see right over here. Okay, this is the NumPy array that you are able to see right over here, guys. Okay, Himanshu, you will be able to find the day 4 days of notes. The first day of note was on the first day itself. Okay, that we have used for the first 3 days, and the fourth day of note as well, like that is there on the first day in the description of the video itself. You will be able to find it from right over there. Okay, again, code bulletin, please focus. We have just started out with the basics. Please focus upon what I'm teaching right now. Don't go off topic, stay on the topic, learn what we are doing right now. Okay, we've just started out with NumPy. Okay, don't go into the advanced topics right now. Is NumPy a part of Python? Yes, that's why we are using it right over here. Okay, yes, of course you can use a list name as well. For example, you are having name Shah is equals to this particular list right over here. okay, then you can directly put it up as SHA as well, because you are basically using a variable, and that variable basically contains the list itself. So this is basically using as a variable. So that is totally up to you how you want to use it. Okay. Okay, so the next thing that is important for you guys is what is ND or N dimension. Okay, Deepesh, I've already told you guys ND or N dimensions. Okay, shape of an ND array. What is the shape of an ND array? That is how many rows and columns does your ND array have. Okay, so for that you use something called as dot shape property. Okay, that is something that you use, dot shape property. Now you cannot have a zero dimension array. You cannot have a dimension of 0. The only ND array, the smallest ND array that you can create is a one dimensional ND array. Are you guys able to understand this? The smallest ND array is a one dimensional ND array. You can have like a one element. You cannot have a 0 element array at any point of time. So the smallest that you can do is one dimension. So one is usually omitted. Okay, whenever you are like writing, if you know that the smallest number is going to be 1, it is usually omitted. Okay, so example, we are creating this ND array right over here called as X. Okay, we are creating, why we are using ND array. Like I said, we have seen the proof as well that NumPy is way faster than normal Python. So that is the reason why we use ND arrays in place of lists, because they are more efficient and effective and faster than your normal lists in Python. Okay. Rashmi, to find the day one notes, please go to the day one video. In the description of the video, we have put on the notes as well for the day one. Please go from right over there and you will be able to see it. Okay, what is the difference? Again, Amol, please don't get ahead of yourself. We have just started with this particular concept, so it will take some time, guys. Just be patient, learn, listen to me properly. Okay. Okay. So right over here, as you are able to see, we are creating this ND array, a one-dimensional ND array right over here. Okay, and we want to take up the shape of this particular array. We want to take up the shape, so we are going to use the shape. Now shape will basically give us the number of rows and the number of columns of this particular array. Okay, so as you're able to see, the number of columns is just 1. Okay, the number of columns is basically, so number of rows in this particular array is just 1, and the number of columns is 5. Okay, the number of rows is 1 and the number of columns is 5. Okay, so the answer would be 5 comma nothing, because you know that the number of rows is 1, so you don't have to write 1. You cannot have 0, so you don't have to specify it. So the shape of this entire NP array would be 5 comma nothing. Okay, that basically means 5 comma 1. So if I'm running this little line, you will be able to see that X as a dimension of 5 comma nothing. Okay, that means 5 comma 1 right over there. Similarly, we can use the type. So we have already learned about type in Python. So you can use type to check out the data type, the type of the object, that is X. So X is basically numpy.ndArray. Okay, numpy.ndArray right over there. Okay, the next thing that we are having is the D type. Okay, that gives you the data type of all the elements present in the ND array. That basically gives the data type of all the elements present in the ND array. Okay, so D type basically gives you the data type of the elements. So here it is giving us int 64. Now int 64 is a variation of integer, because right now you're doing scientific computation. In scientific computation, there are a lot more data types than your normal integer, float, strings, and these are referred to as int 64, int 128, int 256, float 64, float 32, float 128, float 256. You're having Unicode 5.0, Unicode 6, and all these kind of data types. Now this is beyond the understanding of this particular bootcamp, because we don't require to learn it. But if you want to still go and explore what are the different data types that exist in NumPy, we have put a link for you guys right over here in the notes itself. You can go out to this particular entire documentation and read all the different data types that are present right over there. Okay, so that is totally up to you guys to do. Okay, but yeah, we have provided it to you guys as well. So like I said, you are having your shape. Okay, you are having your type and you are having your data type as well. Okay, so these are the three different code. Okay, three different methods that you can apply over your ND arrays. Okay, over your ND arrays itself. Okay, So here is another ND array that basically contains strings inside of it. Okay, here is an ND array that basically contains string inside of it. Shape gives a row comma column. Okay, number of rows comma column, but because there is no like this just one row right over there, the first one, if for a 1D element, will always give 5 comma nothing, or like number of columns comma nothing right over there. But for like normally when you are dealing with shapes, in that particular case you will be getting your row comma column normally. Okay. So right over here, you are having a particular ND array of just strings. Okay, so if I'm running this particular line of code, you are able to see that the shape is 2 comma nothing. That is, you are having 2 elements and a single row right over there. Then you are having the type. So the type of the ND array is Numpy ND array. Okay, and the data type, that is Unicode 5. Okay, so Unicode 5. And of course, check that out as well. What is the data types from right over here? We have provided you guys the link in the notes as well, so you can definitely check that out as well. Don't worry about it. Now, one of the differences, major differences between lists and Numpy ND arrays is that lists can contain multiple data types inside of it. Lists can contain multiple data types inside of it. You can have boolean, you can have integers, you can have strings, you can have floats in the same list itself. But in Numpy ND arrays, you can only contain a single data type at once. You can have an ND array of just strings, an ND array of just integers, an ND array of just floats. You cannot mix the data types right over there. This is one of the biggest differences between lists and ND arrays. The second biggest difference is that ND arrays is very fast and effective when compared to your lists. Okay, so that is what you need to understand. Are you guys able to understand up till here? Please let me know. Are you guys able to understand up till here? Please let me know, guys. See, don't rush ahead of yourself. Okay, we will be looking at two-dimensional ND arrays as well. Don't rush ahead. Whatever I am teaching, understand up till there itself. Don't rush ahead. There's a like, are you able to see this much is left? So of course we'll be covering a lot. Okay, just be patient. Okay, when dealing with Python as well, we covered almost everything. Okay, so be patient. Let us just like proceed further with it. Okay. Great. So it's important to remember that one of the biggest differences with Python lists and ND arrays is that unlike Python list, all the elements in the ND array needs to be of the same data type. Python lists can contain both integers, strings, floats, bool in the same like list itself, whereas in ND arrays you cannot mix different types. Okay, so right over here, if you are having a list, okay, if you are having a list that contains strings and integers at the same point of time, then all the integers will be converted to strings. They will be typecasted to strings automatically while creating an ND array. Is as you are able to see right over here, you will be getting a list of strings because you cannot have different data types in the same list. It's in the same array. You cannot have different data types in the same array. So due to that reason, if you're having a list of mixed data type, it will get typecasted. Now this typecasting has a particular order to it. Okay, this typecasting has a particular order to it. For example, the highest precedence is given to strings, then to floats, and then to integers. Okay, so if you are having strings, floats, and integers in the same like list, and you want to convert it to an ND array, then all of them, if strings are present in that particular list, everything will be converted to strings. If floats are present in that particular list, there are no strings, there are just floats and integers present in that particular list, and everything will be converted to float. Okay, so this is the precedence right over there. For example, right over here, as you were able to see, all the elements got converted into strings. Similarly, if you didn't had a particular string, if you had a float right over here, okay, then every single element would get converted to a float. Every single element would get converted to a float. Okay, are you guys able to understand this? Please do let me know, guys. You guys able to understand it? Please let me know. So how to identify rows and columns? So just think about it. Columns are like pillars. If you think about it, columns in buildings are like pillars. So it's like vertical in nature. So always vertical counting is basically columns, and rows is basically horizontal. Rows are basically horizontal in nature. As you're able to see, the data type has now been converted from like integers and floats to floats itself, okay, to floats as well. Okay, so right now let us look how to create a two-dimensional ND array. Okay, how to create a two-dimensional ND array. For that, let us first try to understand something. A two-dimensional ND array looks something like this. This is how a two-dimensional ND array looks like. You want so just think about it. What is this two-dimensional ND array? Just separate all the rows. Just separate all the rows. Can I represent this two-dimensional ND array as a list? As a list where each of the elements is a one-dimensional ND array? Can you guys let me know this? Are you guys able to understand this? Okay, are you guys able to understand this? Can I represent this two-dimensional ND array as a particular list of one-dimensional ND arrays, guys? Can somebody let me know? Can I represent this two-dimensional ND array as a list of just one-dimensional ND arrays? Can somebody let me know? Can you think about it in that particular way? Okay, so I can write the same thing. Okay, so can I write the same thing as right over here? I can write this as, let's say it's 1 2 3 4 5 6 7 8 9 right over here. 1 2 3 4 5 6 7 8 9, and then the same thing as 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9. And the same thing I can represent it in a single line as 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9. Are you guys able to understand this? Please let me know. Just think about it in this particular way. You are having a two-dimensional ND array. It can be represented as a list of one-dimensional ND arrays. That can be written as a particular like having one list and then having the list right over here. And that we can put it up in this particular way. Are you guys able to understand this? Please let me know, guys. Great. So right over here, as you're able to see, so we can convert this to an ND array. This is how you write a two-dimensional ND array. This is how you write a two-dimensional ND array right over here. So if I'm going back to my like code, if I'm going back to my code right over there, okay, let me go back to my code, and you are easily able to see that I've just written the exact same thing. I've written the exact same thing right over here, and this is how I'm able to create a two-dimensional ND array. The shape of this two-dimensional ND arrays is 4 rows. It contains 4 rows and 3 columns. It contains 4 rows and 3 columns. Except the case of a one-dimensional ND array, whenever you are having any ND array, it will always be row comma column. It will always be row comma column right over there. So you're having the dimensions of 4 rows and 3 columns. Then you can use the y.size property. You can use the y.size property. Now for 3 dimensions, please apply your brain. Okay, if you are able to understand for 2 dimensions, then you should be able to understand it for 3 dimensions as well. Apply for your brain. This is normal IQ. If I've told you guys how to make 1 dimension, if I told you guys how to create 2-dimensional code as well, then it should be very easy for you, a normal IQ based question, to write how to create it for 3 dimensions as well. That is up to you. How would you do that? That is up to you guys to do it. So you are able to see that this y is dot size property. You will be able to get 12 elements. That is the total number of elements that is present in the two-dimensional list. That is 1 2 3 4 5 6 7 8 9 10 11 12. So there are 12 elements present in this particular list that you are able to get using the dot size property. The next is the type. So again, the data type would be numpy for .ndarrays, and the d type will basically give you guys the data type that is int 64. Are you guys able to understand this? Please let me know, guys. Right over here we have written the code for like 10 11 12 as well. So 1 2 3 and 4, there are 4 rows. Okay. The next thing that we want to understand is the like data type conversion. As you are able to see, we are having a array of just integers, an array of just floats, but if you are having an array of integers and floats, it will convert everything to a float. So we have already seen that, so there is nothing more to discuss right over there. So we have already seen that if there is a particular list of int as well as floats, so everything will be converted to float according to the precedence. Okay. Now, what if you want having a particular list of floats or a mixed list of floats and integers, but you don't want it to get automatically converted to floats. You want to convert it to integers itself. You don't want it. You want to force it to be converted to an integer based array. To be able to do that, what you can do is you can just specify while creating the array. So as you are able to see, this is a particular list of floats. This is a particular list of floats. Okay, so you are easily able to see from right over here that we can convert this. Now if I'm just creating this particular list, it will create a particular nd array of floats, but I don't want that. I want an nd array of integers itself. For that, you can just specify d type is equals to np.int64. you want the data type of this particular new array that you are going to create as an integer itself. You just have to specify this additional attribute right over here. D type is equals to np.int64. So it will convert all the elements back to integers. As you are able to see, all the elements of the list are converted to an integer itself. All the elements of a list have been converted to an integer itself. Okay, are you guys able to understand this? Please let me know, guys. Yes, Kiran ji, that's Kaur, that's absolutely clever. You have written it correctly. That will be the code for three-dimensional list itself with two of the height, and then you are having like a length and width of, I think so, 2 rows and 3 columns. Okay. Okay, great. Amazing, guys. Amazing. So Himu is somebody who will be like teaching you guys from tomorrow, because he or she, I'm not able to identify for the name itself, but they think that I don't know three-dimensional ND arrays. Although I've just corrected a particular person who has just written a three-dimensional ND array in the live chat, that they have done it perfectly. It's simple to just like create a three-dimensional ND array. Think of it as multiple two-dimensional ND arrays. You know how to write the code for two-dimensional ND arrays. You're able to create a three-dimensional ND array. So a list of two-dimensional ND arrays creates a three-dimensional ND arrays. A list of three-dimensional ND arrays will create a four-dimensional ND arrays. So everybody is open to their own. It's a free world. But a particular person who has been programming in Python from like I've started programming in Python from my 11th standard. It has been 7 years since I've been programming in Python. I might be knowing a lot more. Okay, great. So okay, so that is what I need to make you guys understand right over here, guys. Okay. So next thing that I want to understand is okay, so this is not important for you guys. Let us leave that for right now. Reshape. Okay, we are going to understand about reshape. So how to create a numpy array without using lists. Okay, so right now what we were doing, the first way of creating a numpy array was by using a list itself. So you use the list and then you converted it to an NP array. Okay, but what if you don't want to convert like you directly want to create an NP array itself without using a list. So how to do that? Let's try to understand it. For that, you are having two particular properties, that is the arrange and the reshape property. Okay, the two properties that are there is the arrange and the reshape property. Now np.arrange, so let us try to understand what does np.arrange do. The code that we need to understand is np.arrange, only one R, okay, only one R right over here, arrange, and then the number inside, okay, then the number inside, whatever number that you're specifying right over here. For example, I specified 5. Well, let us assume that I specify 5 right over here. In that particular case, it will create a numpy array for me, okay, that has the length of 5. Okay, so having 0, 1, 2, 3, 4, and then 5. So this is the entire NP array that will be created for me after running np.arrange 5. Okay, so right over here, it will also contain these values 0, 1, 2, 3, 4, 5. If I'm writing np.arrange 20 right over here, it will create an entire list of 20 elements. It will create an entire list. That line was so bad. Let me just use a shape itself. It will create a numpy range of 20 elements having like starting from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm so sorry, this is wrong right over here. Okay, it will go up till 4 itself because I've used the number 5. So it will be 0, 1, 2, 3, 4. That is 5 elements. Okay, 0, 1, 2, 3, 4. That is 5 elements right over there. Okay, 16. Then you are having 17, 18, and 19. So if I'm specifying 20, it will create 20 elements with the numbers starting from 0 and going up till 19. Why? Because this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As you're able to see, it is 20 elements. Okay, only 0 to 4. Okay, I'm very sorry, like I made a mistake right over here. I went into the counting itself, so that is the reason why I went to 5. But as you're able to see from right over here, it will start from 0 and will go up till 19. That is for 20, it will be 20 elements. So it will create a one-dimensional ND array. It will create a one-dimensional ND array right over here, and it will create 20 elements. Okay, it will create 20 elements for us. 20 elements, that is, we are starting from 0, so it will go up till 19. Okay, because 19 plus 1, the 0th element, that is 20 right over there. Are you guys able to understand this? Please let me know, guys. Are you guys able to understand this? Are you guys able to understand the use of the arrange function? Please let me know, guys. Are you guys able to understand the use of the arrange function? Please let me know, guys. Okay, the next thing that you need to understand is we will then be using the reshape property to convert it into a two-dimensional ND array. For example, if we want to convert this particular array, I want to convert this particular array into a two-dimensional ND array. So for example, x, after using x is equals to np.arrange, we are getting this particular entire a one-dimensional ND array. To convert it into two-dimensional ND array, I will be using np.reshape right over here. I want to reshape the x. I want to reshape x, that is this particular 20 element long one-dimensional ND array, and I want to give it the shape of 4 rows and 5 columns. I want to give it the 4 rows and 5 columns. So it will convert this into something like this. I need some space right over here. Let me just remove everything from here so that I'm able to get some space as well. So if I'm running the new line of code, that is np.reshape right over here, that is x comma 4 comma 5, that is 4 rows and 5 columns, then it will create something like this for me. So it will have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So this one dimension will get converted into two dimension having 4 rows and 5 columns. Okay, now this particular number, this dimension should be the exact same. Okay, the number of elements in this two-dimensional ND array 4 5 is 20. It should be exact same as the number of elements in the one-dimensional ND array as well. Okay, the one-dimensional ND array as well. Okay, so right over here, if you are writing something, you can write it as like 2 10. You can write it as, let's say, 20 1 or 1 20, but all number of elements in that particular shape should be the exact same as the one dimensional ND array as well. Okay, it should be the exact same as the one dimensional ND array as well. Are you guys able to understand this? Please let me know. Are you guys able to understand np.arrange and np.reshape? Please let me know, guys. Are you guys able to understand np.reshape and np.arrange? Please let me know, guys. What is X? X is the one-dimensional ND array that we have created. Okay, so X is equals to np.arrange 20. That is right over here, as you're able to see. X is equals to this entire one-dimensional ND array of 20 elements. Okay, X is this particular one-dimensional ND array, the guys, that we created. This is X. Using X is equals to np.arrange 20. Are you guys able to understand this? Please let me know, guys. Amazing, amazing, great, great. Okay, so let us move back to the code once again. As you're able to see, we can use np.arrange20 to create the one-dimensional ND array. After we have created the, so this is the one-dimensional ND array, that is X. Okay, that is the same that we created, and then we are using np.reshape right over there to reshape the one-dimensional ND array into a two-dimensional ND array right over here. Okay, so as you're able to see in the code, we first use np.arrange is equals to X. Okay, that created the one-dimensional ND array having 20 elements, and then we are using the np.reshape X 4 5 that will reshape it into this particular two-dimensional ND array right over here. Okay, great. So again, you guys have to always use the exact same number of elements that are present. So if there are 20 elements present right over here, the new reshape should also be of 20 elements. You cannot have a matrix. Okay, your matrix is, just think about it. Okay, just think about it. A matrix, a two-dimensional matrix is basically should always look at as a rectangle. Okay, two-dimensional matrix should always look at it as a rectangle or a square. You cannot have a matrix that looks something like this. This is not a matrix. This is not a matrix. This is not possible. So always it is like number of rows and number of columns, and every single element should be filled. Okay, great. Now instead of writing these as two separate lines, instead of writing this as like first np.arrange and then you're doing np.reshape, we can do this in a single line of code as well. You can do this in a single line of code as well. As you're able to see, we can directly write np.arrange 20. That will basically create the 20 element one dimensional array right over there, and then you are going to do dot reshape 4 5. Okay, dot reshape 4 5 right over here. So instead of writing it as two separate lines of code, you're easily able to do it in a single line of code as well. That will result you in the same answer. That will result you in the same answer right over here. Okay, so as you're able to see, we use these two separate lines into the same line. So np.arrange 20 that creates your X dot reshape 4 5. Okay, so that will do the exact same thing in just one line of code for you guys. Okay, so again, like Python tries to make things smaller, so these two are used very frequently with each other. That is the reason why Python has done this. Okay, Okay, so you can of course create this as 2 comma 10 as well. That is no issues. Okay, you can convert it into 2 comma 10, so it will just create like 2 rows and 10 columns right over here. You can put it up as 10 comma 2 as well, so 10 comma 2 as well, that will also work. So it will create you 2 columns and 10 rows. So that is totally up to you how you want to use it. Okay, just make sure that the number of rows and columns, okay, the multiplication, the number of elements remain the same. Okay, great. Next is accessing elements in an ND array. Okay, accessing elements in an ND array. So for example, you are having a one-dimensional ND array, you can easily access them just like lists. Okay, you can access them just like lists using indexes, using your square brackets, using negative indexes. So I don't think so this is something that you need to understand, because yesterday itself we have covered lists. So this is very easy for you to understand. So using the positive and the negative indexes, you can get access to the lists as well. Okay, so that is as simple as possible, guys. Okay, great. So next is modifying ND arrays. Okay, so what about how to modify an ND array? For example, you are having a one-dimensional ND array right over here. How do you modify that ND array? Okay, to be able to like add a particular, change an element, to modify an element from that ND array right over there. Okay, Harshit, Rana, just try it out. Okay, you have the Google Colab link, go there and try it out. Okay, like I said, in this bootcamp we are not going to cover three-dimensional ND arrays, because this is a deep learning bootcamp. We are not going to deal with those type of ND arrays. In the future, if we are having any bootcamp on CNNs, okay, then we will definitely deal with three-dimensional ND arrays right over there. In this bootcamp, we need to only concern ourselves with one-dimensional and two-dimensional ND arrays. Okay, so right over here, as you're able to see, you can change a particular element just like in lists as well. You can just get access to a particular element, that is the index 3, and change it to 20. And as you're able to see, the index at the integer at the index 3 got changed to 20 right over here. So just like in normal lists, you are able to modify the ND arrays as well. Okay, but what about two-dimensional ND arrays? How will I access elements in a two-dimensional ND arrays itself? So like I said, always think about it as RC. Always think about it as RC, row and then column. So you are having indexes on your rows and columns as well. Just think about this particular matrix right over here. Okay, this is a 3 by 4 column matrix, 3 rows and 4 columns. So this also has some indexes. Your row will be indexed as 0, 1 and 2, and your column would be indexed as, let's say, 0, 1, 2 and 3 right over here. So if I want to get access to this particular element, it would be name of the ND array and then in parentheses the row number. So what is the row number, guys, right over here? The row number for this element is 2. Okay, the row number of this particular element is 2 right over here, and then you are having the column number right over here, that is 3. So row comma column. Okay, row comma column, that will give you this particular element. If you want to get access to, let's say, this element right over here, if you want to get access to this element, the row number is 1, the column number is 2, so the element will be name of the two-dimensional ND array and then the row number, that is 1. So always RC, row and then the column, that is 2. So you will get access to the green element from right over there. So this is how you can utilize the indexes of the row and the indexes of the column to be able to get access to an element in a two-dimensional ND array. Are you guys able to understand this? Please let me know, guys. Are you guys able to understand this? Please let me know, guys. Yes, Himanshu Jha, that is, let me just check. Okay. Yeah, Himanshu has written it correctly for a three-dimensional ND array, guys. Okay, so as you're able to see, this is how you are able to get access to the elements using ND arrays. Of course, you are having the negative indexes as well for both rows and columns. So for rows, it will be like -1, -2, -3. For columns, it will be like -1, -2, -3 and -4. So you can use any combination of this. You can get access to this element by using -1, 3. You can get access by using -1, -1. So you can use any particular combination of positive and negative indexes of the rows and columns to basically get access to these elements. Again, just normal indexes of rows and columns, just normal indexes of rows and columns from right over there. Okay. Okay, so I'm running this particular line of code. As you're able to see, we are able to get the first element, then the second element, and then the last element from this particular two-dimensional ND array. That is a 3x3 ND array right over here. Okay, there are, you can go up to like 100 by 100 matrix as well. It's totally up to you. Okay, similar to that, like I said, okay, you can even modify an ND array, two-dimensional ND array. Just specify the element that you want to change and then specify the modification that you want to do. So right over here, the first element got changed from 1 to 20. Okay, the first element got changed from 1 to 20. Okay, right over here, as you're able to see, we have just selected the first element, that is 0 by 0, that is the first row and the first column right over there, and changed the value to 20 right over there. You're able to see that we have changed the value from 1 to 20. Okay, are you guys able to understand this? Again, just selecting that element and modifying it, as simple as that. Okay. Great. So next thing that we want to look at is adding and deleting an element from the ND array. Okay, how to add and delete an element from an ND array right over here. Okay, so as you're able to see, we are having a rank 1 ND array and a rank 2 ND array, okay, that we have created right over here, 1 dimension and 2 dimensional ND arrays. Okay, so if you want to delete, okay, an an element from an ND array, let us look at it from right over here. So we have an ND array, a 1 dimensional ND array right over here. Let's see. Index 0, 1, 2, 3, and 4 right over here. We want to delete the first element and the last element from right over here. Those who don't know what rank is, it was taught to you in your 10th standard of mathematics. Just do a Google search and revise over it. Okay, those who don't know what rank is, just do a Google search and revise over it. It's a 10th standard mathematics. Okay, otherwise for right now, you can just consider it as a 1 dimension and a 2 dimensional ND array. Okay, so we want to delete the 0th element and the 4th element. The name of this particular array, 1 dimensional ND array, is X right over here. So if you want to delete it, you just have to write np dot delete. Okay, please don't write that, please explain again. I was not able to understand. What were you not able to understand? Please write that, because I'm not able to understand right over here. What are you not able to understand? So please write the exact sentence that this is what I am not able to understand. Okay, so if you're not able to understand something, just write it properly. Okay. Okay, great. So np dot delete right over here, and inside of that you want to specify that I want to delete it from the 1 dimensional ND array, that is X, and I want to delete, so the list of all the indexes that you want to delete. I want to delete the index 0, I want to delete the index 4. So that will get the new array as just the indexes 1, 2, and 3. For example, if the numbers were 15, 16, 17, 18, 19, so I'll get the new array as 16, 17, and 18 itself. I've deleted the 0th index. Okay, I've deleted the 0th index and the 4th index from right over here. So np.delete X, that is the 1 dimensional ND array from where I want to delete. Okay, and then you are having your 4, that is the last element that you wanted to delete from right over there. Okay, I don't know what is X equal to. X is equal to a 2 dimensional ND array right over here. Okay, X is equal to a 2 dimensional ND array. Okay, as you're able to see right over here, it's a 2 dimensional ND array. So yeah, just focus upon the code, you will be able to understand it. Like, there's nothing to be not to be able to understand from right over there. Okay, as we're able to see, so for example, if I want to delete just the second element, okay, I just want to delete the second element, I just have to write np.delete, delete from X. I want to delete, then the element I want to delete, that is 2, and that's it. So it will just delete the element 2, and I will be able to get 15, 16, 18, and 19 as my answer. Okay, 15, 16, 18, and 19 as my answer right over there. Okay, Are you guys able to understand this? Please let me know, guys. Are you guys able to understand np.delete for one-dimensional ND arrays? Please let me know, guys. Okay, so let me show you the attendance link for today. Yeah, as you are able to see, we are able to use, like, you guys just have to provide the list of all the indexes that you want to delete. You can delete like more than 2 elements, 4 elements, 15 elements at a time as well. Okay. So how to delete it from two-dimensional ND array, that is the next topic. Do not worry about it. We are going step by step. Please be very patient. Okay. I'll show you the attendance link for today, guys. Okay. We'll continue this from tomorrow onwards. The first 15 to 20 minutes will be finishing off in Numpy in tomorrow's class, and then we'll be starting off with AI machine learning in tomorrow's class as well. So please be ready for it. Okay, please be ready for the same, guys. Let me just open up the attendance link for today. This is the Python and deep learning bootcamp. Okay, and day 4 out of that. We create the attendance link. Send link, copy, close, response, QR code, P, download, 4 July. So this is the attendance link for today, guys. You can scan it and continue it from there itself. Okay. See, guys, certificates, you will be receiving it. It will take some time. There must be a problem right over there. We have to do a lot, many number of things. So it will take 1 or 2 days, but you will get the certificates. Don't worry about it. Okay. Okay. Okay, so as you're able to see, the certificates have been sent to many people for the previous boot camps. So don't worry about it. It will take some time, but you will get the certificates as well. Okay. So yeah. So thank you so much, guys. We'll meet tomorrow again in our class. Again, we'll be having it at 8 o'clock itself. And yeah, thank you so much, guys. Thank you.